Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. The AWS Pricing Calculator is designed to help you forecast costs before you build. Instead of waiting for charges to appear on a bill, you can estimate what workloads might cost by modeling the resources you plan to use. The goal is not to produce an exact invoice, but to provide a structured view of cost drivers. This allows you to plan budgets, compare scenarios, and explain trade-offs to stakeholders before committing. On the exam, the cue to remember is that the calculator is a planning tool. It gives structure and foresight, not guarantees. Its value is in helping you see which inputs matter most to your design. The first step in building an estimate is to choose the region and the currency. AWS prices vary by region because infrastructure costs differ worldwide. By selecting the right region up front, you anchor your estimate to the context that matters. Currency choice ensures you're communicating costs in a format your finance team expects. From there, you add services one by one: compute, storage, networking, and any others that make up your architecture. This method mirrors real-world design. You don't buy the cloud all at once. You assemble building blocks. The calculator reflects that modularity. For each service, you input drivers that directly affect cost. In compute, this means vCPUs, memory, and instance hours. For storage, it means capacity in gigabytes and expected request patterns. Data transfer fields let you model egress, inter-AZ, or inter-region traffic. Each of these levers can move costs significantly. On the exam, if a question asks about which inputs most affect cost, the right answers are usually usage-based drivers, like instance hours, data transfer, and storage size. Recognizing these drivers ensures you use the calculator effectively in both test questions and practice. Storage class selections and lifecycle assumptions add another layer. You can choose S3 standard for frequently accessed data, standard-IA for infrequent access, or Glacier for archival storage. Lifecycle transitions can also be modeled, letting you forecast how costs shift over time. Database estimates work similarly. You select an instance class, add storage, and factor in input/output operations. Serverless services like Lambda use different inputs, requests, and average duration. Containers rely on task or pod counts multiplied by runtime hours. Each service has its own pricing model, and the calculator guides you to enter the right drivers. Networking components are equally important. NAT gateways charge both hourly and per gigabyte. VPC endpoints and load balancers charge by throughput or requests. By adding these components, you capture the hidden costs that can surprise teams. On the exam, if the question highlights include networking and cost planning, the cue is NAT, endpoints, and load balancers. These often go overlooked, but they can have big financial impact at scale. The calculator makes them explicit, reminding you that network architecture is not just technical, but also financial. Support plans can also be included in your estimates. These range from developer support to enterprise support, each adding a percentage of your AWS usage costs as a fee. The calculator allows you to add a placeholder for this so that estimates reflect not only infrastructure but also operational support. Notes and assumptions are another valuable feature. They allow you to document the scope of your estimate, clarifying whether numbers reflect peak usage, steady state, or just one component of a system. This transparency makes estimates easier to review and defend. Once you build an estimate, you can export it or share a link for review. This collaboration step is key. Finance, product, and engineering teams can all view the same structured data. Versioning is also helpful. Many organizations keep a baseline estimate reflecting their first draft and an optimized version reflecting saving strategies. By comparing these side by side, you can show how commitments, lifecycle policies, or caching impact cost. The exam may cue this with phrases like compare scenarios. The correct association is the calculator's ability to hold multiple estimates for analysis. Comparisons are especially powerful when looking at on-demand versus commitment-based models. For instance, the calculator allows you to toggle between on-demand, reserved instances, and savings plans to see the effect on total cost. This helps organizations weigh flexibility against savings. On the exam, when you see, quote, compare on-demand to reserved pricing, think of the pricing calculator. It provides the structured way to test options and communicate trade-offs before making commitments. The final exam cue to remember is this: the pricing calculator is about structure, not guarantees. It organizes inputs, instance hours, storage, requests, and transfer, and shows you how they translate into dollars. The actual bill may differ because of usage variability, discounts, or new pricing. But the calculator teaches you to see which levers move cost the most. That skill identifying cost drivers is what the exam really tests. If you remember that, you'll recognize the right answers when scenarios mention cost forecasting or planning tools. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A good way to begin using the pricing calculator is to start from reference architectures. Instead of adding random services, think about a typical web app or a data pipeline and build estimates around that pattern. For example, a web app may include an application load balancer, an auto-scaling group of EC2 instances, RDS for the database, and S3 for storage. By mirroring these building blocks in the calculator, you create a realistic baseline. On the exam, if you see estimate cost of an application stack, the correct association is using the calculator to model reference architectures, not guessing service by service. Utilization factors are the next adjustment. Not all environments run at full production load. Development and test systems may only run part-time. Production may run 24/7. The calculator allows you to model these patterns by reducing hours or scaling instance counts. For example, you might estimate that dev servers run only 40% of the time. This shows how utilization directly reduces cost. Exam questions that mention apply utilization factors or dev/test environments are pointing to this idea. Always remember that not every workload runs at peak constantly. An estimate should reflect that. Growth multipliers and elasticity ranges take your estimate from static to dynamic. Growth multipliers let you add expected expansion over time, while elasticity ranges show how usage scales up and down with demand. For example, you might model a 20% yearly growth in storage or a peak load that doubles traffic on weekends. These tools make estimates more realistic and show stakeholders how costs might evolve. On the exam, cues like account for growth or scale with demand connect to using the calculator with multipliers and ranges. Overheads must also be included. Observability services like CloudWatch, CloudTrail, and Config create logs and metrics. These generate storage and request charges that many teams forget. By adding these into your calculator estimate, you get a truer picture of cost. On the exam, if you see include monitoring and logging costs, the right answer is to remember that observability is part of the workload. Costs are not just compute and storage. They are also the tools you use to watch and govern them. Stress testing with peak versus average loads is another important step. Workloads rarely run at one level all the time. A retail site may average 100 requests per second, but spike to 1,000 during sales events. The calculator lets you model both averages and peaks, showing financial impact. The exam may phrase this as test with peak loads or model seasonal traffic. The key is that estimates should reflect not only steady state, but also surge scenarios. This gives you a realistic sense of upper and lower cost bounds. Network choices also make a big difference. You can model egress directly to the internet or through CloudFront. CloudFront reduces both performance impact and cost. By comparing the two in the calculator, you see the savings potential. Exam scenarios may highlight model egress options or compare CloudFront to direct delivery. The correct connection is using the calculator to demonstrate cost reductions through caching. Networking is often the hidden cost, and the calculator helps bring it to light. Commitments are another lever. The calculator lets you toggle between on-demand, reserved instances, and savings plans for the same workload. This shows the delta in cost between flexibility and commitment. The exam may describe steady baseline workloads and ask how to estimate savings. The right response is to use the calculator to model reserved or savings plan scenarios. This highlights how commitment models reduce cost for predictable usage. Validating assumptions with Cost Explorer is a valuable follow-up. Backcasting comparing calculator estimates against historical usage helps you check accuracy. The exam might frame this as validate estimates with past data. The correct tool for this is Cost Explorer, which provides real usage patterns. In practice, this ensures your forecasts are not only theoretical, but grounded in how your workloads actually behave. Risk buffers and unknowns should always be documented. Estimates are never perfect. By including notes about what you don't know, such as growth rates, request counts, or user adoption, you give stakeholders context. The calculator has a notes field for this purpose. On the exam, a cue like document assumptions and unknowns connects to this practice. It shows that estimates are not just numbers. They are models with boundaries and risks. Ownership is another governance factor. Attaching tags or assigning cost owners ensures accountability for the estimate. This ties the forecast to the team that will manage the workload. On the exam, if you see, quote, allocate ownership for costs, the answer is to tag and assign owners. Estimates are more useful when someone is responsible for them, and AWS tagging practices support that link. Review cadence is critical. Costs must be revisited with finance and product partners regularly. The calculator is not a one-time tool. By reviewing estimates quarterly or at major milestones, you keep financial planning aligned with business needs. The exam might phrase this as ongoing collaboration with finance. The right answer is review cadence, not static estimates. This shows AWS's philosophy that cost awareness is a continuous practice. Common pitfalls are easy to avoid if you know what to watch for. The biggest is forgetting data transfer or request charges. Many teams estimate only compute and storage, leaving out the small costs that add up at scale. The exam may describe, quote, estimate missing request charges or surprise egress costs. The correct link is that the calculator requires you to add all dimensions compute, storage, requests, and transfer. Leaving any out produces misleading results. Communicating results is another step. Sharing both monthly and annualized views helps stakeholders see both short-term and long-term impact. The exam might describe, show yearly costs for planning, and point to the calculator's reporting. This is about framing. Cost estimates are not just technical, they are also financial communication tools. Finally, estimates must remain living documents. Once workloads launch, telemetry from AWS usage should feed back into the calculator to update assumptions. This keeps estimates aligned with reality. On the exam, cues like update estimates post-launch connect to this practice. It shows that AWS cost planning is iterative, just like cloud operations. Estimates guide design, but real usage refines them. The calculator is a living tool, not a one-time exercise. From an exam perspective, the key lesson is that the AWS Pricing Calculator provides structure, not guarantees. It helps you capture cost drivers, compare scenarios, and keep estimates aligned with usage. By remembering to model compute, storage, transfer, and requests, and by validating with real data, you use the calculator as AWS intends, a planning guide for cost-aware design. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.